Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments, where tonight we're going to expand your digital classroom and hopefully use pictures to raise your students' awareness of the world around them. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. I'm excited to be joined by our two panelists, Veronica Carlson and Kim Thomas. For 35 years, Veronica has taught mathematics at Moon Valley High School in Phoenix, where she most recently taught college algebra. Veronica is also an adjunct mathematics instructor at Glendale Community College. She's presented at many national, state, and local conferences. Veronica enjoys working with teachers, helping them to integrate TI technology into their classrooms to help students have a greater understanding of mathematics. Veronica, thanks for joining us tonight.
Happy to be here.
And Kim is in her 26th year of teaching high school math and is passionate about using technology as a tool to explore and understand math. Kim is currently teaching geometry and BC calculus. She has 5 years of experience as well as an AP calculus reader. And as a T-Cubed instructor, Kim enjoys working with teachers, helping them to incorporate strategies for teaching with graphing technology. Kim, it's great to have you with us.
Wouldn't miss it for anything.
We're expecting a large crowd, so your audio is muted. Feel free to send any questions to Kim or Veronica using the Q&A window on the right side of your screen. We'll also be using the chat window to send general messages. As a reminder, the session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. We hope you don't have any audio issues, but in the event that you do, try selecting audio at the very top of your WebEx menu and choose Audio Broadcast. At this point, Veronica is going to discuss our agenda.
Well, hello again and good evening. And tonight we're going to learn how to insert an image into a TI-Nspire document using software. We're going to also discover how pictures can be used in the classroom. And we're going to create TI-Nspire documents in which students can graph on top of an image. And we'll show you a variety of different ways that you can do that.
Veronica, thanks so much. And Kim is going to discuss our expected outcomes.
So by the end of the webinar, we are hoping that everybody can insert an image into a TI-Nspire document, create a TI-Nspire document in which students can graph on top of the image, and then also make sure that you can find images of mathematics all around you.
Thanks so much, Kim. Veronica, you should have control. Feel free to share your screen.
All right. Thanks, Mike. So this evening we're going to use pictures. And so the first question that I have for everyone, and I'd like you to use your chat, is have you ever used pictures in your classroom? So go to your chat and send it to everyone. And I'm going to pull down my chat so I can see what you guys are typing as well. And we'd love to have participation. So that just helps everyone to give us a little feel for it too. And so have you used pictures? And I'm seeing, yep, no. All right, so we're having a variety of different answers, charts and graphs and not yet. And so one thing that's really awesome with TI-Nspire Premium software is that you can use some preloaded images that Kim's going to show you, or you can use your own images. And I had an opportunity to go on a transatlantic outreach program. It's called Top Tour. It was for STEM teachers. And if you're interested in more about that program, you'll have access to my email at the end of tonight's webinar. And I invite you to send me an email, and I can give you more information about that program. And the pictures we're using were taken when I was in Germany. And so I'm showing a picture on my emulator right now, and I'd like you to tell me, what do you notice? What do you wonder about that image? I'm going to go over here and show it. So it's tiny, but you're not answering on, obviously, my emulator, but I have it set up if we had a navigator, a TI navigator, that we could use that in our classroom. But again, go to your chat window, and what do you notice and what do you wonder about the picture that you see in your screen? What do you see there on that picture? What do you notice?
And Veronica, can you go back to the big picture of that? That might help.
Absolutely. Yep. And you help me.
I'm going to go ahead and read off some of them, and please have them keep coming in. So the pitch of the roof on both the left or the right with a question mark. Can we use this for a slope discussion? And talk about the state. Is this the same house? Lots of angles. One side of the house is steep. We have parallel and perpendicular lines written in here.
Good.
Opportunity to measure slope.
So I'm going to interrupt you. What I'm looking for, too, is there something different in this picture, how I have it set up? You guys are saying awesome things as math teachers, but just looking at the picture right now visually, I don't want to say non-math, but is there something that you're noticing about the picture? And maybe we just need to say it.
We are seeing some things about right triangle, similar right triangle proofs, right triangle possibilities.
Does the picture look really bright to you guys? And do you see a grid on top of it? So those are the basic things that when I'm even in my classroom that I try to have students even tell me about it, because normally when you see pictures you don't see grids. But you guys are all on track, and we're going to see this picture again, and all of those questions are going to, all of those responses will totally be used. And so what we did is we took a picture of a house, and whoops, I'm going the wrong way, and we put it into a graphing form so that you can graph on top of it. And that's what Kim's going to show us right now, is how to insert a picture into a TNS document. Now, you have to use software for this, and it would be best if you could just watch and see the different that Kim does, the different keystrokes to do that. And then this webinar, all the webinars are recorded, and then you can go back and look at it again for reference. And we also have something else to share with you. So Kim, I'm going to go ahead and make you the presenter.
Okay.
And you can take it from there.
All right. So this is my TI-Nspire software. And my job right now is to make sure that you know how to insert an image into a TI-Nspire document. And while Veronica and I go around and we take lots and lots of pictures, we are not professional journalists, no. Nor are we professional editors. And so, someone was mentioning transparency, and what's really nice is that it's really not that hard to make this work in my classroom. And so this is our document that we're working on, and we took a picture of a thumbnail, so it was a very, very bad low image before we even put it in there. But I do use that in my classroom just as markers for when I'm leading lessons of, hey, you're here. And I don't want you to read it off my screen. I want you to read it on your paper. And so sometimes I'll actually put really bad images into an Nspire document to keep students going.
And Kim, that document will be shared with participants when the webinar is uploaded to the education.ti.com website, and then you'll be able to download that document that Kim just made reference to.
Right, and it has 4 steps to it. And I'm just going to start with inserting one. So I'm in a semi-new document here, and what I'm going to do with this is I am going to insert we're going to start with a geometry page. And so when I'm starting with the geometry page on the TI-Nspire, I know that it's a geometry page because it tells me that I'm in the flat plane, and I have some units up here. And from this piece in the software, I'm using my little insert up here, I now can insert an image. So this isn't something that you do on the handheld, it's something that you do on the software. And then you share it with your students on their handhelds. So I'm going to pick an image, and the last place I happen to be is the folder that happens to have photos that we're sharing with you at the end of this evening. And I'm just going to pick the spiral picture right here. And so once I put that image in here, I now can do things with it. So I can right-click on it, and it'll ask me, do you want to select that image? And by doing that, I can do things with it. So I can move it around in the corner. So I'm just kind of translating it on my plane right here. I can also get some different selections. And as I'm selecting it, and it requires a little bit of, I can manipulate that picture. I'm definitely distorting that picture when I do that. But you do have some control over that. Not great editing, like I do most of my editing before I put that onto the screen, but this is the bright and shiny picture that happens to be on top of the geometry page. And we can insert into almost any of the pages of the TI-Nspire. But what's nice about using the geometry page is that the next thing we're going to do is we're going to press menu, and we're going to change the view to graphing. And as soon as we do that, it's now behind the scenes, and it's that transparent piece. So I didn't have to do a bunch of different editing software magic in order to make this picture now one that my students can actually work with. And so now at this point, it's just a matter of deciding, where do I want to put my axes? And a lot of people mentioned that in the chat of you purposely place the axes here in order to do that. And you're absolutely right. So now I have infinitely many problems I could do with this picture. I could start right here, and I could start graphing lines, or whatever we want to do. So that's how you make it transparent. And so I'm going to go ahead and insert a new problem. And this time I'm going to just show it one more time. And with this one, so again, I started in geometry.
Kim, also just show how to hide that scale, just in case our participants this evening don't remember how to hide that scale in the upper right corner on your page.
So the cool thing is that you don't have to. So as soon as I turn this menu view into graphing, that scale goes away because it's no longer a geometry page. So that's one thing, like I'm in the habit of hiding that scale when I don't want it, and that's an extra step that you don't need to do, which is kind of nice. But if you did want to, you would just hit, I'm just going to add another geometry page. And so if we're up on that scale you can actually just kind of click into it, and I can change it. So now I'm measuring meters. Or if I right click on it, then I can just hide that scale.
Yeah, good.
So we talked about your software already comes with some pre-made images. And so when you're in the Content tab, so I don't know if you can see up here, this was my Document tab. And in the Content tab, that's kind of telling you what's kind of on my computer a little bit. But inside the TI-Nspire CX folder, so these are things that are on my computer. Here's my TI-Nspire CX. There's a folder called Images, and there are 11 images that comes with the software that TIers have taken, and then they have put onto the software for us to use. Now, you can't preview them from that folder. So what I did is I've already inserted them in here just so that you can see other images here. So here's the first one, the second one, the third, another bridge. I think this is bridge 3. This beautiful fence. I love the Ferris wheel. And then this is from Washington, D.C. The balloons. A nice little circle there. And the tulips. So you do have a bunch of files already preloaded that you can play with, and it really is all about your imagination and what you want to do with these images. As we are kind of exploring them and using them in our classrooms, you know, mathematically or just for instruction, because any type of JPEG, BMP, or PNG image can be placed into a TI-Nspire document. So I've been known to just kind of snip pictures from my worksheets and put them into files as well. Again, sometimes for students to interact with them, and sometimes just as markers of this is where we are in class and what we're talking with. So I have not been watching the chat, but
I think
are there any questions?
There's a question, Kim. It says menu, then where? So I think that's for inserting an image that was asked. Maybe you could just show where these preloaded images. These images came from TIers when they were creating the Navigator system, and with, of course, the TI-Nspire premium software. And those are given, you have full rights as a classroom teacher to use them with your students.
So again, it's in the content tab, and then it's going to be in the TI-Nspire CX folder. And there's, again, once you start using your software, like my software has different things in there, but one of the folders that's preloaded is called Images. Inside of Images are the 11 the ones added to from TI ahead of time. And so that's where you would see where those are at. And then if you're going to insert them, you kind of have to pay attention of where that path is on your computer in order to put them in there. And so hopefully that answers that question. If we were talking about this menu.
Gotcha. No, we got a gotcha. I think we answered the question.
Then I think we're good. All righty. So I'm going to send it back to you so that we can actually work with some of these pictures. So Veronica, you now have control.
Okay, I'm going to share my screen. We don't do this every day, so that's why we're helping to talk it through with each other.
It's so nice to have a co-teacher.
What we're doing, so bear with us. Thank you so much. And also, we're used to now hearing at least a few peeps and stuff. I know you're muted on purpose, but it's different teaching with no voices in the background. All right, so again, these pictures came from a transatlantic outreach program STEM tour that is open to math, science, teachers of technology, and it was a 2-week all-paid trip in Germany, and I did this summer of 2019. And so the first image that you're going to see is of a funicular, and this is located in Freiburg, Germany, and Freiburg is kind of in the Black Forest, and yes, they have excellent gummy bears there. And a funicular, if you didn't know or you're not familiar with it, it's a different mode of transportation which uses some cable traction for movement up on steep incline slopes. And it's a passenger vehicle, and it's pulled on a slope with a cable, and it's in the loop. And so it was very interesting to me. There's funiculars all over different places in the world. I know there's one in Paris as well, and one in Lugano, Switzerland. So here is a picture of a funicular. And as you did last time so wonderfully in the chat, we're going to go just with this image, so not that it's transparent or that there's your grid on top. And I think you guys know, what do you notice? What do you wonder? What math can you connect to this picture? So go to that chat window, if you'd be so kind, and chat it up. How do you think you could use that picture? What do you notice in the picture? What do you wonder about the picture? Can you connect some math to this picture? And right away I'm seeing linear expressions. Oh, excellent. Parallel lines. So those are things that I saw right away. And so let's go. Since Kim's taught you how to insert an image, yes, we could do speed. I don't have the speed for you, but that would be certainly something else that we could do. And so I've set up this. Kim just showed you how to do this. And so sometimes students need a reminder as to how to get that graphing line up at the top page. And so you're going to go and you're going to push tab to have that done. And you know what, I'm going to go, I was here and I'm going to go in my function form. So this is generally how it comes up into function form. And I know that I have what type of a line here. I can insert a line, and I can kind of guess about what the slope would be. I'll say 2x, and I can also 1, 2, 3, 4, 5 plus 5 for y-intercept. And let's see. Well, I forgot that negative. So one thing that you can do, or that on this TI-Nspire that you can have students do, is if you're in a freshman class and you're learning how to graph, we can also just go and we can translate it and rotate it just by moving the line. And so it's going to match up pretty good. I can also translate it here. But that's one thing that you can do, is you can use this and these tools, the rotate tool and the translate tool, so that you can go and find the equation of a line. And so here I have a really nice one. So 2 is a little too steep. And anyways, you can do that. So I'm going to go ahead and I'm going to delete that. But also, Kim, what are you telling us? It's a great opportunity to, perpendicular lines too. Yep, that's good. I'm going to go back to this one and I'm going to turn that off so that I don't see that. And I am going to go and I would like to graph in relation mode. And that's the mode that my graphing line was in originally. And the way that you do that is I push delete and I can go back there, backspace, and then I can go to relation number 6. So I'm going to take this off for a second though. And so if I wanted to use graphing by zeros, that would be something else that we could do. And I know here that I have an x-intercept at 3, and I see that I have a y-intercept up here at 5. Now, one thing, I want to make sure that I have an extra page. Yes, I do. So one thing you can do as the creator is you can go and you can grab the axes, and I can change it that way. But I want to go and I can change the position of it. So you, as Kim showed you, you're in control that you can change that however you want. And so that's something I think is super slick. You can also go and change the scale, and I can go and change my scale easily if I want to, just by double clicking. And I can change the size. I can make it larger. So you have a lot of creative license, if you will, that you can do whatever you want to that image. Okay, so let's go back to the one that I had kind of preset up there. And does anyone want to put in what the equation would be into the chat window if I have a x-intercept at 3 and I have a y-intercept at, let's say, 5. 1, 2, 3, 4, 5. I'm in relation mode, and it took me out of relation mode. I'm going to go delete and go back in relation mode. And in standard form, thanks, sorry, Kim, said it wrong. And just to save time, 5x plus 3y is equal to 15. And then remember, you can move those labels off to the side. And so matches up pretty good. It's a little off right there. And that's one thing, I'm not an editor to change my photo. But in terms of classroom use, there's lots of lines there that students will be able to get the gist of. And I do remember someone, I think, mentioning parallel lines as well. So that's a funicular. And that was that's our first one. And so we're talking about a linear. And so let's do another one. This one is very interesting. And there's a vehicle called a Unimog. And we went to go see the Unimog Museum in Gaggenau, Germany. And Unimog, it is an acronym, and it's not really, I'll say, a clean acronym, but it's Universal Motor Gerät. And a Gerät is a German word for device. And so they look really kind of funky. The Unimog it's a range of multi-purpose all-wheel drive, and it's a medium-sized truck, so it's not ginormous, and it's produced by Daimler, but it's sold under Mercedes-Benz. And Daimler-Benz took over the manufacture of this Unimog in 1951. The thing that's really cool about a Unimog is that it has two axles that work independent of each other. So there's our whole group, and this is a picture of a Unimog up there at the top. And so, of course, I have a picture without the group there. We'll just make them disappear. And let's do the same thing that we've done before. What do you notice? What do you wonder? Or how could you connect math to this picture? So go ahead and chat. And Kim and Mike help me here. Oh, definitely using the art teacher. That was great.
So for this one, we didn't ask if everybody was an algebra teacher in here. But are there other applications also to consider with, I'm going to say, geometry as well? I see we have tangent lines, tangents to a curve, graphs of circles. Again, this would be a great connection to circular motion. Mm-hmm. It's kind of hard to take a static picture and turn it into motion. But that would be the next step. Inscribe circle and a triangle. Ooh. Vertices. So even to use the picture to talk about vocabulary, our academic vocabulary, that's an awesome way to do that.
Awesome. Excellent. All right.
Another question, well, what's the diameter?
Yeah, now I have to say I did not take measurements when I was there, but what I saw instantly, and again, what I think I'm just ingrained with functions, is absolute value. And so I'm going to show you a couple of different things with absolute value. First of all, I want to make sure you know where the absolute value template is that you can use. We can also look at our transformations to see where we're at, and this looks like we're at a -3, and 1, 2, 3, 4, 5, 6, about 7, and we'll have to kind of guess that stretching or compressing factor there. So let's go ahead and I'll go tab. And I'm in a different problem up here, so now I'm still in function mode. And I'm going to get a fraction. And I'm going to cheat a little bit because obviously I've done this. The absolute value, here's your template, your math template button, and your absolute value is over here. And so sometimes students forget where to get that. That was over at -3, so I know I need to change that to a +3, and it translated, vertically translated up to about 7. So that looks pretty slick. So it looks really nice for an example of an absolute value. But you're right, there's lots of different things you could do. Now, just like I tried to translate the line, this does not have that capability. The absolute value function does not have that capability for a translation like that. But one thing we could do is use translation through sliders. And so I'd like to do this again using sliders. And so I'm going to go here, and there was that one. And here I can insert a slider. So I'm going to go back and get my function line. And then I know that it's a stretch or compress factor of A. The thing you have to remember is that I'm going to have to say it multiplies by then the absolute value. You cannot have it implied multiplication. It doesn't understand that. And then x minus H, and then out of the absolute value, and then plus K. And then I'm going to push enter. Now, it should come up with, do you want to have sliders? But I'm realizing my errors because I practiced this, so I'm going to move to this page where I have it already in place. And it's going to say, do you want A, H, and K to be sliders? And all you have to say is yes, and then these are going to pop up. Now, a couple of things about sliders is I can do different effects with the sliders. So here I can move it around, and I can show the different translating. And so this is really nice for students that sometimes forget that it's opposite. And see if I can make this a little bit better. Match up. Stretch factor. Okay. And then with sliders, things that you can do is I can right-click on the slider, and I can go to Settings. I did change the step size to 0.1 instead of letting it be automatic. I can go up here, and I can also change which slider I want to have different values or minimum maximums. So it's kind of a one-stop shop there that I can do that. I can also right-click on the slider, and I can minimize them. So I can make them a little bit smaller, so then that way they don't take up as much screen. And then the other thing that I think is kind of one of my favorite things is I can animate it. And so I could just let that keep going, and then students can also see the value and see the animation all at once there. So, and then just to stop the animating, I can stop animating, and then it stops. Okay, so sliders are really helpful and useful in the classroom, especially for discovering, and students can, once they kind of learn how to insert them, you can insert them very easily and quickly. Kim, are there any questions or comments in the chat that I need to address?
I am not seeing anything, but I do know, like, having that skill of using a slider in the classroom, it's good for students to do. You know, that's something that has come up on the fly in my classes every once in a while. I'm like, let's just try this with the slider real quick, and it doesn't always have to be clean and done ahead of time with the teacher, even though, you know, for lots of instruction it is appropriate to do so too. So that discovery piece is really nice.
And
with the sliders.
Important. Yeah, and important, and it helps students to have a, you know, really better understanding of what's happening. You could also crop the picture, and again, you could just use it for slope. You could talk about steepness. You could just find the, you know, determine the equation of a line. Sometimes you can move that coordinate, and you could have the same picture, but you've moved that coordinate grid in the background, so it turns into another warm-up problem. I've always, you know, did those for quick pull warm-ups at the beginning of class when we were in class together, just I try to use these pictures still, just it's used in a different way. So here's an example of that one. The next picture, I'm going to hand it off to Kim in just a second, but I took the picture, so I just wanted to mention that this one is from a ceiling, and it's from a vocational education school in Gaggenau. And Germany is very, it's very important for all to be educated. It doesn't necessarily mean that everyone's university bound, but that everybody has a skill. And you can go to this Carl Benz School in Gaggenau, which is a vocational school, and it focuses on metal technology and automotive engineering and mechatronics. And the thing that's really neat is graduates can make a decision. Do I want to continue to a university and earn a degree, or do I want to take a state exam to become a qualified technician? And anyways, it was just very interesting. And so I'm going to pass it now to you, Kim. and then you can show that ceiling.
All right. So I'm going to share my TI-Nspire. And so we have the document here, and this is the picture of the ceiling. And so lots and lots of different things that we can be thinking about with the ceiling here. And so I'm going to ask you in the chat to kind of follow our same pattern here. What do you notice? What do you wonder? What kind of math can you connect to this picture? How might you use this in your classroom? And maybe you might want to consider adding content to it. And so someone already mentioned right now, reflections.
Mm-hmm.
And so definitely we are reflecting. And reflections, I can think of reflections in different ways right now. So I can think of reflections as functional reflections or as geometric reflections.
We have a great one with lots of geometry, alternating interior angles, corresponding angles, alternate angle, vertical angles. Oop, they're all flying in here. Triangles, slopes of parallel lines,
triangles. And on this picture, you can kind of see where you have these other lines in here. So it's kind of like you have triangles inside of triangles. It's really, really kind of, when you see the sharp image, that's always kind of see there, sine and cosine graphs. Sine and cosine graphs. I'd like to know how sine and cosine graphs might be coming into play here. But we do have something that's repeating, something that's periodic in here, so I could see where the sine and cosine graphs are coming from as well. And every time I look at this picture, I see different things about it. But when Veronica showed it to me, I said, we're going with sequences. And she's like, what? And I said, nope, we're going with sequences. So let's kind of think about how we're going to go with sequences on this one. So I put the image in a geometry page, showed the graph, made it transparent. And that's where, if you actually have it on your handheld, you'll see those faint lines in there. But if this was on my projection board, there'd be no way. So that's something in there. Oh, someone just mentioned tessellations too. So there's lots of different things in here. And so what I wanted to do with this is I wanted to look at sequences. And so we're going to go to our menu. Actually, we're not going to go to our menu yet. We need to get our graph entry line before we do that. So you can double click into it and that will bring it up. The other way you can do that is you just press the tab button and it'll bring up the function line. And I could put absolute value graphs on here and they would be reflecting of each other. So I would have one facing down, one facing up. And, you know, for the most part, if you take the picture right, everything will be congruent. But if you're not dead center in front of something, it'll be a little bit off. And that's always a good thing to talk about with kids too, because pictures can distort reality as well as they can reflect reality as well. So what we're going to do is we're going to hit Control Menu, and we're going to change my graph entry line. So at this point in time, we've talked about functions. We've talked about relations. There's also equation templates where you can do different things with that, which is really kind of cool. And there's parametrics. There's polars, scatter plots, sequences. So we're going to go into sequences, and we're just going to do a regular sequence. We're not going to customize anything. And so sequences are functions. Our inputs are in, and so this is going to be U1 of n, and we're just going to write in our sequence. And someone mentioned sine and cosine in there. So that's actually where we're going to kind of start with this. So one thing that as a BC calculus teacher, I deal with sequences, and I tell my students that, so a sequence is discrete points, and our n's are whole numbers, starting with 0. So we can have 0, 1, 2, 3, 4, and 5. And so what I wanted to do with this, and I'm going to go ahead and hit escape right here, is I wanted to start here at the origin, plot up, plot down, plot below, so on and so forth. Because I'm not going to get the whole grid with one function here. And so one way to do that is to kind of think about something that's periodic, and someone already kind of told us about sines and cosines. So I'm going to use 3, and I'm going to do the sine, and I need to take the sine of something. And so I'm going to go ahead and do the sine of, I'm going to do it wrong, of n. And I'm not going to give an initial term, but I'm just going to kind of go and see what happens. And so when I did the sine of n, a sine of 3n, I did kind of get the right place, but I didn't do everything else. So I need to think about some other things because I'm counting the sine at 1 and the sine at 2 and the sine at 3, and I need to be able to kind of hit all those markers. And so I'm hoping that in that conversation with my students who know trig, that they would think that, oh, maybe we need to multiply that by pi halves. And so now when I'm talking about 3 sine of n times pi halves, and this isn't going to be exact because it's not exactly in the middle. Here we can see that we're starting at that point, going through 2, going below, going above, and kind of hitting again. And so looking at that graph, that's pretty good right here.
That's
now,
awesome.
what if I wanted to get at the origin? So some things that I might want to try with this. And so I'm going to go ahead and hide this at this point in time. And so I right-clicked on this, and I'm going to hit the hide menu because it kind of gets in my way. I'm just going to press the tab again, and I'm going to go up. What happens if I start that at 0? And so now my first value here when I input in is at 0, so I'm looking at 3 sine at 0, then 3 sine at 1 pi halves, then at 3 sine 2 pi halves, and so on and so forth, and I can evaluate those problems. And I would like to finish this up, right? So how can I get the bottom ones? And so hopefully you're thinking, well, couldn't we just reflect it? So I'm going to type that one in as well. So it's going to be negative 3 sine of n times pi halves. And if you notice, I'm kind of like typing everything. I'm not using the keypad. So when I'm using my software, I type out all these things. I very rarely touch a handheld. So when I'm using theta, I even type out theta. And so I'm going to go ahead and I'm going to change this to 0 since we kind of know what we're doing here, not 10. We're going to, I have a feeling that I messed that up.
You need your inequality.
0. How about a less than equal to? Is that what I need?
Yep.
There we go. And so there we are. And so I've at least hit the vertices.
Very nice.
Of this. So I can see how I'm going to use this in my geometry class tomorrow right off the bat. But I would like to also kind of connect these. So what I'm going to do is I'm going to select this blue one right here. And on the handheld, if you hit Control Menu, that's when you're going to get these different things here. So I'm going to touch the attribute one here. And it's talking about what type of points you want. So I can change those. I really do like the solid blue ones. Do I want to show the name? I don't. I just hid the name. But right here, now this is a sequence of discrete points. And that really is something I want to show my students. But for this picture, wouldn't it be nice if we connect them and we can see that path? Because I wasn't going to get that path visually unless I did a bunch of different piecewise graphs. So that's one way we can connect them so that I can trace the movement from this point to this point down to the other ones. And so now if I want to do the same thing with the red one, it says that I'm on sequence graph U2. Again, I'm hitting Control Menu, or if I just hit right-click on my computer mouse right here, it is an attribute. So this isn't mathematically connected, but sometimes we connect things so that we can understand them. I'm going down here, and I'm changing that so the points are connected. And so this is one way that we can actually see that we have this sequence that's bounded above and below. It's alternating from above and below as well. And yet at the same time, it's always just going to keep on bouncing. It's never going to go or converge to one point. And that's something that I think any student could actually grasp, especially after they've kind of learned a little bit about the unit circle, which we're doing in Algebra 2 now. So is it possible for us to give kids the formula and then have them plot the points? That's another particular application of this. So is it a setting in your video offerings? Okay. So I don't know what those questions. How do you blur your background like that? Oh, that's something else. That is a WebEx feature. So just because my background is really, really super busy. So are there any questions about the sequencing on this? And so I just think that that's kind of a really cool way to look at this a little bit differently, and not always, well, sequences are functions, but not always in function mode on the graph. All right, so I'm going to send this back to you, Veronica. I don't see any questions like that. And we're going to get to, really, I hate to say it, but I think that is my favorite picture. And we talked about it in my class today. So I'm excited to see what teachers have to say about it. All right, so you are now presenter.
All right, I'm going to share my screen. And we just finished up with those. Whoops. And there we go. I think that ceiling turned out really nice. And so the pictures that we're using in tonight's webinar, the ones that I took, and there's going to be a couple that Kim took as well, those two will be shared with you so that you can use them in your classroom. And also this TNS file that we're using this evening will also be shared with you, so you can totally dissect it and delete what you don't want and keep what you want. And so that's our gift to you for tuning in this evening. So the next image is, they call it an Eco Station, and it's an eco station. It's in Freiburg, and it's a place of extracurricular learning that offers a wide range of opportunities for students to discover nature and the environment. And I have to say, I'm very excited. This was a picture that you had seen already earlier, and because of the sake of time, I'm going to go ahead and not spend a lot of time on what do you notice, what do you wonder, because we've already talked about it when I was looking for it to be transparent and to have a graph on top of it, but you guys were looking at all the mathematics. But again, as a college algebra teacher, one concept that my students really struggle with, and I don't think I'm the only one, is piecewise functions. And when I looked at this little kind of greenhouse, I saw, oh my gosh, this is a perfect piecewise function. And so that's what I'm going to use it for, to demonstrate how to graph piecewise functions with you as well. So you already know how to do this part. We've already done that. We know how to put a graph on. And again, just because of time, I'm going to go ahead and input them a little bit quicker just to help us so that we can get to the piecewise part. But I want to show you a couple of things. And so plus it's 6.49. So here's that graph. And again, remember, you can move these labels around. Students become very adept at moving those labels around. And again, you can also use these and collect the screen image, and you can put those into your smart notebooks or your PowerPoints or notes for students, whatever kind of information you're doing. If you're using Google, you can put them into Google pages and share again with students. So I can have, here's one equation. Again, if I want to do another equation for the other side, we have a negative slope and 0.19 x plus 8.37. I don't know what's faster, either using the keyboard or the keyboard. I feel like I'm slow both ways. All right, so that's a nice example, and definitely we have two different functions, and that's what's cool about a piecewise function is that you can put these together. We can put constraints on here, just and I'm going to show you how to do that. I can double click on this and I can edit it, And let's say that I want this graph to be less than or equal to 0. So I'm going to go over here and I'm going to use my such that key, and I want all x values to be less than or equal to 0. And so I can put a constraint on it. And same thing over here, I can put a constraint on this one. Now this one I could say less than or excuse me, greater than or equal to 0 because it's not a piecewise function. But we have to remember when dealing with piecewise functions, there can only be one owner of the fence. That's how I kind of describe it. Who owns this fence? And so that's something that's very difficult for students to understand, because to be a function, it has to pass the vertical line test. And if I have one function combining both and both of these points are here, well, takes it out and can't be a function that way. So anyways, let's go ahead and look at this, and we'll enter these functions in as a piecewise function. So you can do lots of cool stuff here. So even if students aren't using a piecewise function, and here's the house again. And I worked really hard to get this grid in a nice spot. I'm going to get my function line, whoops, wrong one. I'm going to get my function line up, and I'm going to go to my math template again, and I'm going to get my piecewise function template. And from here, I know what those are, and we've kind of seen them, and we discovered that. So it was 0.37. I'm going to go ahead with 0.4x plus 6.5, and then tab over, and I'm going to go from -6 less than or equal to x. Whoops. I'm trying to hurry, and I don't want to make a goof. And that's going to be less than or equal to 0. Okay, now down here, my other equation. And the one thing that I can't do is I cannot have two different colors. I wish I could, but I'll say TI, if you're listening, I would like these to be in two different colors.
But it's one single function.
Yes, it is.
That wouldn't make sense if it's one single function that just happens to be
two parts.
Well, this one is discontinuous, so it's one discontinuous function. So
what a great example, because sometimes we don't see those discontinuous examples either.
No, that's one thing that, like, this picture just has so many things going for it and so many different applications.
And then we're going to go 7, less than or equal to 7. So again, you can also talk about who owns the fence, making sure it is going to graph correctly. And then let's go ahead and enter it. And there we go. And so I think that really works nicely as a live example of a piecewise function. One thing that is new with the CX2, with the TI-Nspire CX II, is that there's a new way to trace, which I'd like to show you. I'm going to go to Menu, Trace, and Path Plot. I'm going to trace. This is a function. It's a piecewise function. And so I'm going to go select Function. And this tells me that I'm in a trace mode, and specifically Path Plot. And this is my little play. I'm going to move this. You can move this all around the screen. So I'll move it over here, and I'm going to go ahead and start playing. And plot, plot, plot. And look at that. Is that so great? And I can go and I can pause it. And I can see what's happening there. I just think that's fabulous. And I think
so question in there for your piecewise function, it does not have to be a compound inequality. It just needs to be functional. And I think you can fake what you write as functional, but it should be functional because we do good mathematics. So yeah, it could be x is greater than 0 and x is less than 0 between the two of them.
So I was going to try to make the line weight a little bit thicker.
Yeah. So it looks
Yes.
like we
So
can
as
go
long as you
through.
have constraints.
Yeah. Looks like we can do one last example really super quick.
As long as you have constraints. Okay. So, I'm going to pass this off to Kim. And then I know you're all cheering. Yay, that was awesome.
All right. So our last one is we wanted to make sure that we kind of touched on all the different types of plotting features that you can do, thinking about all the graphs. And so this one is a Colorado blue columbine, and it's a flower. I don't know where I found this flower, but I did take this picture of this flower purposely because I am on a mission to teach polar and to have students understand polar graphs conceptually. And so when I look at this, I see a polar graph. And as we're looking at it, there's things that we can notice and wonder. We can do all kinds of different stuff with it. We could talk about Fibonacci things. But really, I just wanted to plot this really quickly here so we can look at this. And so, again, we would press our tab to get our graph line. I don't want to deal with functions in this case, so I'm going to hit Control Menu, and I'm going to change my graph entry to polar. And I could do this with parametrics as well, but I chose to do this one with polar graphs. And just because we're getting really short on time, this isn't one that I can plot exactly, but as I'm teaching my students about polar, there are things that we could change with this. And the beauty of everything is if they were to mess with some different numbers. So I'm going to change that to 3 theta right now, and that's definitely not it. But, you know, before my students even know about polar, they might say, well, there's 5 petals here. What if we change that to 5? So the whole piece is that we do want to have students explore. We do want them to kind of think about some things. And polar with PathPlot is my favorite. And you are in control, so I'm hitting the right arrow here, just making it go. Or I can go backwards and talking about that right there. If I hit the up arrow, we can trace it. And that's just kind of a nice feature to kind of play with things so that students can explore. And notice how now I'm repeating. And so that's what happened there. And so it's a nice way to bring up those questions that we might have just told students about. And so that's just something we wanted to make sure that we took care of. And
I think
so
that's beautiful. I love that too.
Polar is one of my favorites that I want to bring into my geometry class.
There are just a couple of comments about that some of these pictures could be used as 3-act lessons, and I agree. I think that would be good, and having students make predictions. And then another question or comment came up of how could students participate. You know, a lot of students, most of my students have cell phones, and I invite them to look for math around them and to share pictures with me. And then we, in fact, have done that, and where the students then, I turn it into a picture, and then they go find the equation, or they go graph it, or they go, I send it to the students, and they have to kind of figure out what was the student intending, just like what we were asking you with what do you notice, what do you wonder. So anyways, you're going to get access to these things. You have to wait till the webinar recording is uploaded, and but you should get information about that, or Michael will say something, and then you will have access to the photos, the how to insert a picture document, as well as our TNS file that we use this evening. All right. I think, Kim, you want to hand it to Michael?
All right. Michael.
Sorry we didn't get to the last picture, but that you saw was a spiral, and that's, I think, a favorite too. That came from Disneyland.
Thanks so much, Kim and Veronica. Really quickly, I just want to share on our website, education.ti.com. This is going to be our last webinar of the 2020 year. But if you're looking to maybe extend that learning into next year, 2021, feel free to visit our website, click on professional development, and then webinars. And we started under our live webinars. We started including some of our early January and February webinars that we're going to be hosting on Tuesday nights. So if any of these are of interest to you, please feel free to register for those. Again, they're all free. And if you can't make it live, by registering, you automatically get a follow-up email with links to the recording, the documents, and the certificate as well. Speaking of a certificate, please go ahead and click the link in the chat window to receive your certificate as well as a link for the documents that were used tonight. And if you're watching this on demand, go ahead and copy that link into your favorite browser to receive your certificate. Big thanks to Veronica and Kim for everything you shared tonight. Thanks so much.
Woohoo!
Thank you.
And thanks everyone for joining us. Hope to see you back online in January. Have a great night.